Hi, everyone. We are entering into week 12 of our learning. So we are in unit 3, module 4. We're continuing on with chemistry calculations, and this will be the second last week of chemistry calculations. So that means that next week is our last week. So hopefully you are caught up. This week, we're going to recap mole ratios. And what you would have learned is that these coefficients out front in a balanced equation, we are going to think of them as mole values rather than molecules. So instead of saying 2 molecules of hydrogen, we're going to say that we have 2 moles of hydrogen. Reacts with 1 mole of oxygen to yield 2 moles of water. So from now on, coefficients are referred to as moles. We're going to just take a couple more examples of how to do mole ratios, do a couple of practice here to make sure that you understand how to set those ratios up. Again, that was covered in the last module a little bit more in depth, so you can certainly go back to that if you need. Then we're moving on to what is referred to as mass problems. And there's a fancy word that we use in chemistry called stoichiometry. Stoichiometry is just a fancy word that allows us to figure out how much of something we have in a balanced equation, and we can predict how much of another item, whether it's a reactant or product, that we need, or how much we can make in the end. So there are 2 different ways that you can go about this. You can use a 4-step method on how to solve these type of problems, or you can use what's known as a dimensional analysis method. And I'm going to show you both, and you can choose which one sort of speaks to you. So in this lesson here, this is a lesson sheet, and I take you through 2 examples. Again, if you don't have the capability of printing these sheets out, you can certainly just do these on a separate sheet of paper or in your 3-ring notebook like I've asked, and you can follow through and do these 2 examples so you have them as references. Okay, so here's a summary of what needs to be done in these 4-step solution process for mass problems. Here are just a couple more examples that I take you through. And then this is method number 2 of how to solve these mass problems using this sort of grid box. It's called dimensional analysis. So I'd like you to kind of watch both and figure out which one you prefer. It doesn't matter to me which one you use, just as long as you're sort of consistent, okay? And then there is a problem set. There are 4 questions actually. I do one question so you can see the exemplar of how I would like your solution to look if you're using the 4-step method, and if not, you use the dimensional analysis method. But you always need to make sure that you are showing your work and you are showing your final answer with units, and your solution follows like good formatting, right? So that's part of showing your communication, and it's easy to follow. So submit that to the Dropbox when you're done. And we get into something called percent yield this week. And percent yield basically is a measure of how efficient your reaction is. So you want to think of it like a percentage on a test. So if you, let's say, got 5 out of 10 on a test, you know that your percentage would be 50%. If you got 8 out of 10, you got 80%. So what we're looking for in the lab is we want our experimental value ideally to match, in theory, our calculated value, so what we should be getting. So those are called theoretical yields and actual yields. What you want to do is read through and definitely copy out some reasons why it's very rare to get 100% yield in a lab. And here's some common errors. So go through those. You definitely want to go through some of these sample calculations, and what I would like you to do is copy out some of these from the video. There is a different approach using the dimensional analysis method again, okay, of how to do that. And then you've got some practice to do. I'm not collecting it, so you want to assess your understanding, but there is a lab that follows that you need to demonstrate your understanding of how to do mass, and percent yield. So you have to do the practice ahead of time in order to be successful on this stoichiometry lab. Okay. So if you have any questions along the way and you're getting stuck, please reach out because I can always create a personalized video for you to help guide you and help you through any problem areas. Okay, take care, everyone, and have a great week.